Here is the mix about when we predict ions. It doesn't just happen, okay? Going from neutral to a positive or neutral to a negative just doesn't happen by itself. What you actually have to do is you have to put the two atoms together and usually add a little heat for that to actually start. When the electrons start to move from one to the other, we start to become charged and they snap together and hold because of the attraction between the positive and the negative. And so there's some conventions about how we put together compounds, and this cartoon actually does a really good job. Perhaps one of you gentlemen would mind telling me just what it is outside the window that you find so attractive. Okay, there's some good things about this, all right? The cations are positive, just like the females. The anions are negative. You can make an assumption there. But really, this is probably one of the most important parts. In the South, who goes first? The lady or the men? The ladies go first in the South, and the men go last. Well, here, the ladies are positive cations. They always go first when you write a compound. If you reverse it, it's wrong. And so the cations always go first. The anions always are written second. All right? And so you've got to watch out for that. Also, when you make compounds, when we make these negative and these positive ions, when a compound is formed, what happens is we form a compound only when the overall charge becomes neutral. So we have to combine them in ways so that everything cancels out and becomes neutral. And that is a key for compounds. And so every time we are going to solve something, you need to have a strategy. Okay? Doing chemistry problems has nothing to do with being smart. It has to do with figuring out a game plan on how to approach something. Okay? And if one strategy doesn't work, we can change to a different strategy. But here is one strategy to approach making ionic compounds. All right. So this strategy is to create binary, meaning two elements or two ions coming together to create a compound. Knowing one, that compounds must be neutral. Number two, we predict the charge for each ion that is in the pair, and you just did that. Number three, we compare the charges. So you look at one atom and you look at its charge, 3+, and another atom and it has a 1+. Will that ever become a compound? 3+ and a 1+? No, because what do two of the same charge like to do? Do they attract? No, they go away. So if you ever get two things that have the same charge, you're never going to make a compound. Okay? But if you have a 1+ and a 1-, well, plus and the minus come together, and 1 and 1, if it's balanced, you just write them together because they have made a neutral compound. So you look at the number and you look at the charges, and if they cancel each other out, you've got your compound. But sometimes what happens is you got a 2+ and a 1-. Does that cancel each other out? No. So we have to do something. Okay? And what I'm going to do, I'm going to call it the crisscross method. And really, if you follow the crisscross method, and I'll show you what that is in just a second, it is doing math without doing any math. I like that, right? And so what we're going to do is we're going to drop down numbers, okay, into subscripts, and we're not going to worry about the charge, okay? Last thing that you do, okay, review the subscripts, okay, when you put them together. If they can be reduced, then you must reduce them by whatever common factor, okay? That's the last step. Some people forget that step, okay, but it can get you every once in a while, all right? And so, here are some practice problems, all right? Sodium can react Okay, if I look at the periodic table, we've done sodium a couple times, but sodium has 11 positives, and for it to be a perfect number, it has to go 10. So sodium becomes a plus, 1 plus. Bromine, on the other hand, has 35 electrons when it starts, but after it reacts, it has 36, so it becomes a -1. Okay, so I predicted the two charges. Now my next thing is to take a look at them. Does a +1 and a -1 balance out? Yes. So I simply write the compound, meaning that I put those two together with no spaces in the middle. That's great. The next one I gave you something with a little extra information. Sn is called 10. One of its charges could be a +4. Okay. The oxygen, on the other hand, becomes a what charge when it reacts? A what? A -2. Okay, that is great. So now both of them have charges. I look at that. If I bring a 4 and a 2 together, is that good? Does 4 and 2 balance each other out? No. Okay, here's what the crisscross method is. I take this 4 and I put it down. I take that 2 and I put it down. And I become SN2O4. Okay. Now, last step. What do I have to look at? Can those numbers be reduced? Yes. What would I divide each of those numbers by? 2, and then it would become SnO2. Now let me show you visually what this looks like. The sodium has a plus, and the bromine has a minus, and it's balanced. This one over here, the tin, has a plus and a plus and a plus and a plus. 4 pluses. One oxygen has a minus and a minus. And another oxygen has a minus and a minus. Oh, that doesn't look like 2 minuses. Has a minus and a minus. If you look at the tin, there are 4 pluses. And you look at the 2 oxygens, there's 4 minuses. And look, they're the happiest place on earth. Okay? And everything's balanced. All right? Work on the next 4. What would you predict the compound to be between those particular ones? Okay. The potassium and the sulfur, the potassium becomes a +1 when it reacts. The sulfur is a -2. When I look at them, they don't balance each other out just one by one. So I'm going to drop down a 2, and I'm going to drop down a 1. Now on my strategy, I say you only drop down the number, you never drop down the sign. Okay? And remember, chemists are lazy. And so if you write S, you don't have to drop down 1 because writing S indicates at least you had 1. You only have to write a subscript if it is 2 or more. Okay. Strontium becomes a +2. Nitrogen becomes a -3. They do not balance directly. Sr3, N2. Aluminum becomes a +3. Chlorine becomes a -1. There's the compound. Magnesium +2, iodine -1, not directly. So 2 goes down, 1 goes down. And those are our compounds. Okay? None of them had to be reduced except for this one. And it's easy to forget that last step, but make sure you take a look at that last step to make sure that they are reduced. All right. Now, on the periodic table, we can actually deduce or guess, not guess, we can actually determine what charge many of the elements can actually become. But there are some unruly characters, okay? The ones in the transition metals, that block in the middle, they are complex, okay? They don't follow the rules. And so, for many, almost all of the transition metals, they don't become just one charge. They actually have the possibility of becoming multiple kinds of charges. And so, we actually find in the Earth them in several different charges. So, if by chance I have to ask you to predict one of those, I have to give you a little bit more information. Another two that fall into that same category is number 50, SN10, and number 82, PB lead. And did you see on this sheet, I gave you a little bit more information. I told you which charge that we're going to use. We're later going to give that information in a different way. So any element in that transition metal block, or for us using tin or lead, we have to know which version that we're using, because there's multiple. The other ones that are near the edges of the periodic table always react only one way, and they can only become one charge. All right? And so you have lists of charges for ions, and you can see a couple of them have multiple charges, and they can be one version or the other. And so the ones I want you to understand are copper, mercury, iron, tin, and lead are the ones that, for exam purposes, that you might encounter. Okay? So over on that side, it's really the big elements or the ones in the transition metals that are kind of weird. The rest of them have very easily predictable charges. All right. So ions can be created directly from elements. But there's another column on that sheet, and I'm handing this out because you can read this one. You might not be able to read it on the little PowerPoint. Okay? There are groups of elements that come together and become ions. So that entire group has a charge associated to it. And so ions are not just single atoms, but can be, I gave you three, can be groups of them. All right? Now, if I was in the regular semester, you would have enough time to memorize this entire sheet. But right now, we're moving much more quickly than that. So I will tell you this. On the exam, you'll get a periodic table to use. I'll print one up that's nice and fresh and give it to you. So you don't have to memorize the periodic table, or you don't have to strain your eyes to see that one. You'll have it close. I will also give you this sheet to use, because I want you, more than memorizing this, I want you to be able to think through the process and come up with the correct answer. Okay? Because this is just a lot of detail that you would have to cram in your brain for just a short period of time, and you don't have enough time to really engage them completely. But what I do want you to do is have enough practice, and I'm going to give you some other sheets to work on, is to recognize that some groups have charge, and that you have to look up the charge to make sure you know what it is. Okay? Most of the groupings is one element combined to oxygen in some way. That's many of how we find elements on Earth, because the oxygen in the air, a lot of things are reacted to oxygen. There are a couple of oddballs. Ammonium is a derivative of the base. You might have used ammonia to clean things. That is the only group that has a positive charge in our listing. The other really oddball thing is cyanide carbon and nitrogen together to make a -1. Has anybody ever heard of cyanide? Where do you find cyanide? In murder shows. It's rat poison, and it's not just rat poison, it's poison if anybody ingests it. Okay? And so there are groups of atoms that behave and act as an ion. Okay? And so when we do compounds, we could, by chance, instead of having an element and an element, you might have an element and a group. Now the element you might be able to predict using the periodic table, or you can look up on the sheet because you'll have that for the test. But when you see a group, you're going to have to look up on this sheet, or you might do it enough to memorize it, but always look up on the sheet to make sure you're okay, so that you know what charge that group is. Okay. Now, let me give you an example of something that you have to watch out for. Okay. The example would be something like this. Magnesium and PO4. Okay, those two reacting. Now magnesium, that one's one you can predict. It's an element, it has 12 electrons, and it reacts to become 10 electrons, so it becomes +2. But it's also on the list. So you can know that two different ways. The phosphate, unless you've used it a lot, you don't know what that is. It's a group of things put together, and that group has a -3 charge. Okay? So I'm at the stage that I predicted the charge of the first ion and the charge of the second ion. Okay? And then I look, a 2+ and a 3- doesn't balance out just coming 1 to 1. So what's my next step? Crisscross, right? A 3 goes here and a 2 goes there. Now be very careful. Watch this. Mg3, that's good. And if I write very quickly PO4, 2. Is that correct? No. Because what that says is I got 3 magnesiums, I have 1 phosphate, and I have 42 oxygens. Okay, the way it's written. I need 2 of the PO4s. To indicate that, I have to use a parentheses. That changes what it says. What this means is that I have 1, 2, 3 magnesiums as a +2 and 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 a +2. And I have PO4, PO4, 1, 1, 1, 1, 1, 1. I have 6 negatives and I have 6 positives. But if you wrote PO with a 42 there, that's a group that's totally different. Actually, it doesn't even exist. Okay, so you have to use parentheses if you have more than one group. Okay, so if I do this, NH4 plus Cl, NH4 is a group that becomes a +1, Cl is a group that becomes a -1, and a +1 and a -1 balance. So I would write it NH4 Cl. I do not use a parentheses there because I only have one of them. And chemists are lazy, and I'm not going to write an extra pair of parentheses if I don't need it. So only use parentheses if you have more than one. But you have to use parentheses if you have more than one, or you change the meaning of what you're looking at. All right? You guys have been working really hard. If you create, I give you 2, 8 more compounds that have at least one group of atoms,